So, good night again. We'll be talking about FPTS and IOTS, which is in functional programming. So, who am I? I worked in IT for about like 14 years, back and forth for back end and front end. And for the past 2 years and a half, focused on the front end. Like when I moved to Portugal and to Dev Experts, I focused on the front end. I loved work the back end, and I don't miss because it's projects here are really interesting. So what are we gonna talk about? There's some made up concepts that like it kind of seems complicated at first, but then it helps you guys understand for those who never worked with it. And what is FPTS? It's a TypeScript library programming for functional programming. And for those who maybe not know functional programming, like if you work with front end, you probably already do functional programming, because it's like, in long story short, it's working with immutable data and in a procedural way, like more functions than object-oriented. And so it has a lot of like concepts like optional value, either value. Is it an error or a valid one? Like, and a lot of other stuff. And TypeScript, probably most of you know, but so what is this? It's just like typing a JavaScript, so so it's good for compile time work. So like, because when you transpile the code, the process that it does when you build your application, like all the types are dropped, and then it's just JavaScript, because there's no TypeScript in the browser. So, okay. So first concept, the container abstraction. Like when you work with FPTS, like everything, like a value become a value inside a container. And this container might or might not have a value, which kind of makes it a Schrodinger value. And so, for example, like when you have this container, it is thrown out into a pipe. So everything goes into this pipe, and then what is inside this pipe makes it a valid or not valid, a valid or absent data. So it gets simpler. So, like, so this is it's everything. It's in piping, and you probably use this in a lot of other languages and applications. Maybe not knowing it, but you probably did in the past. Which means is, for example, in the option case, you might have a data or not data at all, but you only know is in runtime when you check it if this state, like of the container, Schrodinger data. For example, this is the declaration of the option type. So again, the tag type is important. It holds the state. And if it's some, it means I can access the value property. How do I use it? So in this case, like daily basis code, I have normally talking about React again. We have props with some optional fields, and sometimes you have like complex objects that have some concrete fields and optional fields. So how do I use it? This. So you can see that optional field, straightforward string, optional, but person, if it's concrete, and for example, I wanted to access documents, it might or might not exist, and then passport, and then I go to country or number, which is concrete. So in some component, how do I use it? I have the optional field, like simple string optional, and I create the container, in this case, using the function from nullable option, like the way they created this container, this imaginary container, is using this function. So I created a container and throw into the pipe, and then if I'm in the pipe of valid data, all these functions will be called. So I can map the data but only if it's existent. So I don't have to worry about if I have no data, if it's nullable, if it's undefined. I don't care. I have code for when it's valid, when it's there and not absent. And if at the end I might not have a data, I have a default value. But if I have, then mapping blah blah blah, it's my data and what is written in the screen. Again, now for the person type, I created the container from nullable. And then I have this special function for the valid data pipe. I'm in the valid data pipe, so I will process it. And then I take person document, it's optional, so I let this guy does the work for me. So it's like a middleman. Okay, it might or might not be there. So if it's there, I wanted to continue to map it. Oh, sorry. I wanted to continue to map it, so I wanted to reach passport, and then passport, those properties are concrete, so yeah, so I can just map it. And again, if optional person, it's not there, or any of those fields are not there, it jumps right off to the absent pipe, and then I can use the default value, get or else. And then from that, we go to the either type. So simple as that, it's either left or right, which means when I throw this in the pipe and I start validating it, it can become a error, normally for the left side, and a valid data from the right side. So data comes into the pipe, I start to validating using chaining and validating everything. If some error occurs, it goes right to the left data, and I don't need to worry about doing anything in the valid pipe, in the right pipe. It only goes there. Need to worry about if it's there, right? So straightforward props. I have this object with a password confirmation for login forms when you have to compare if they are equal. And I have this validate password function, and it returns me an either. So I have the page, everything, daily basis. When I wanted to validate, I will call that validate function. And then when it's in the right data pipe, I can map it. So let's containerize it. So from predicate creates the container, throw into the pipe. This function, this predicate will say to me, is it valid or is it not? And if it's not, there's the error that it should throw. In this case, I just wanted to compare if it's equal, so I just map it to true. But then it goes Boolean only if it's valid. If it's not, I have an error. So it's either one or another. And I even can map, okay, I have functions to the right side of the pipe, functions to the left side of the pipe. So again, I don't want to worry the kind of data. I don't want to check on map left if it's valid data or not. I know for a fact that it's an error. So I just, okay, what should I do if it's an error? And the opposite in the right side, in the mapping functions. Just if it's valid. I don't have to check if it's an error. It's valid, I know for a fact because I validated before. So let's see how to use it. Let's see that function inside the component. I call it, passing my payload, and I check, is it an error or is it not? So if it's an error, I get access to the left property, which is absent when it's right because of the TypeScript typing and erasing. And so I can check it and then do something with the error. And if it's not, if it's valid, do something with the valid data, right? Okay, but just more ifs, right? Why bother? So that's the key of this library, chaining, because everything is following a pattern and everything is pluggable. So let me create another validation that I wanted to do with the passwords. I wanted them to be like minimum some length, and I wanted to I have say to the user, okay, I have to have at least this minimum, this length for the password. So this is that function that we saw before: payload, container, condition to be valid or not. What can I do to it? I just plug it more validations. So I'm using this another function, utility function, 6 array. I can have a list of validations, and then I start to validate them. And they go to the filter else only if it's valid. They go to the right pipe only if it's valid, because if it's not, okay, blow away, just stop right there, give me the error. So it's a fail early kind of stuff. Then if it passes, then I have the other conditions and so on. So that means that I can add as many validations as I want. So, and everything is reusable, these validations, you know. So if we have like functions for validate some specific kind of minimum charge doesn't know that it's meant to be for password. It's just there and doing their job, like doesn't know what it is. And it's one pipe, one data coming to it, being mapped, so it doesn't create other types of exits, other type of objects, unless, of course, you map them. So let's see some real code, right? This is from the project that we're working on right now. Password validations. It has to have one capital letter, one number at least. And because we have like a special message for, do you have a capital letter and a number, I can like customize the way it validates. So this is a little bit more advanced, but if you start to work with it, like it makes sense real fast. I created a denotative validation, which means in this first line here that, okay, if both validations fail, I want to have a message that says that you failed to not have a capital or a number. If not, one at a time. So this is how we used. I plugged into even more stuff into this chain of validations. Main length, like whitelist symbols, the message for that function when it doesn't have like both things that I wanted. And then this is how we use it inside the component. Validate the current password, validate the new password. Like for example, in here, is it the same as our current password? Is it different from the confirmation? And then we have more stuff that is hidden to have a better readability. And we have a lot of utility functions. In this case, I grabbed all these pluggable objects because current password, new password, and all of those three are, in this case, a object that extends either, but in this case, let's say that's either. And they are all in here, and then if all of them are okay, if all of them are valid, then we go forward. If one of them fails, then it blows up. So, and then you have like one source of truth, which is this pipe when one error, and if not, you have the valid data. So this is the signature for both. So it uses either. So it's either one and another or both. So when you validate, you can choose to keep both values. And why is that? This is the component that we have, and I wanted to have like if present. I wanted to have a valid, like I grab the valid to the input, or empty. If there is an error, I grab the error from the same object, map it, and if it's not present, because it's optional, it's using the option in here, I just like empty string, so no errors, right? So this means that these things it's held in one object, like the data that the user typed and the error that it's presented, and then that is all contained in that object. So it's all the validations, create this object, and you can then revalidate again, put back into the chain of validations, and then reuse it everywhere. And aside from that, there is a library that's kind of the same guy created for runtime validation. That is the IOTS, and it uses everything that we saw before, like either and everything, to create a validator, like describing a type and validates everything. It's kind of, I don't know if you guys used this joy validations, like describing an object, what is the rules for it, and then you call it to in an object to validate it. So in this iOS library, you create a type, and then you have this special function brand. Then where do I start? Okay, I want it to be a number, but I want it to be a non-negative number. So I have a function for validating, just a name for me to use it later. And then when I use it, I have this decode function. And then, okay, is it valid? No, because I want it to be positive. So left, either left and right. Okay, again, the same representation, the left pipe. So how do I use this? I can create like these special validations and functions that are, how do I use this? I can create message direct to the user, or I can create mapped errors that I can use it to handle this data validation. So in this case, I just like created a special message for it. So non-negative, got an invalid valid, right? So again, it sounds a lot complication for just validating a number. But the thing is, we wanted to validate complex objects, right? So this is, again, a code that there is from a real project that we're working on. So we have a wallet, a crypto wallet, and have all that fields like string and number. And now I see that we should have used non-negative in the index. Yeah, exactly. And you can see that in BTC wallet and ETH wallet, I used the object that I created up there. So like I created and reuse it, all the objects, just describing them. And they know what to do, because when I try to set in field that is supposed to be a string but it's not, then it throws an error or a number, or in this case, this complex object, wallet IO, and so on. So let's validate even harder. Let's create a message that says, okay, this field should be this, but then we got that, right? So I have on this special, the errors that the library produces has all these fields and all the information that I can use in this context object. And then when I pass an invalid object, so there it is. Just like I defined, I have the field name and the message that I expected, like BTC wallet. Like I got like nothing. I expected this complex object, and so on, you know. And what it is a left, is a neither. So again, you can throw into the pipe and validate it again, like chaining, plugging. Everything is pluggable. Success, right? So again, one simpler example from our code. In this case, we just wanted to validate if it's an Ethereum address that's valid. So we start from string for a non-empty string, which is another custom object that started from string, like same signature, same stuff, just one created on top of another. What do I start? For the non-empty string, and then I have this isAddress function that it has all the validations for the non-empty string, right? And this is how we use it, like in a real code. For example, in this case, we get this encrypted data. Then when we decrypt this string, we parse as a JSON. Okay, now I got a JSON. I decode it, and when I decode it, if I don't have an error, I have the wallet groups, in this case typed. It's not only validated the structure, I have it typed, so I can, again, have the signature, I have compile time validation from TypeScript, everything, and then just chaining more stuff. So how hard is it to add it to my project, right? Since that might be complicated. Yeah, it's nothing, because you can like increasingly add it to your project. You can add like small validations in some fields as properties, and then you can start to use it like in services, and then like you can start to have components that receives it as props. So it can start like in real small steps, and it has it's tree shaking friendly, so it won't create like it won't increase your final bundle a lot. And yeah, and IOTS is optional, so you can start really small and then using more and more. And so that's it. That was what we saw tonight. And questions?